हम्म. तू ऍग्री किती केलंयस? 2000 ऍग्री.
Good evening, everyone. Shall we start the session? Yes. Today we are diving into an exciting and increasingly critical topic in engineering, that is circular economy projects. As future engineers, you play a vital role in designing system, especially that minimize the waste as well as the maximize the resource efficiency, and especially to create the sustainable solution. Also, it's one of the major responsibility for engineers. We will explore real world case studies where engineering innovations has successfully implemented circular economic principles. Today's sessions, we are going to see few case studies prove that circular economic principles are not just theoretical, they are being successfully applied across the industries. As engineers, you have the power to rethink the design, optimize the resource use as well as that innovative for sustainability. Whether it's through smarter materials, energy efficient system, or waste reducing process, your work can drive the transition to a circular economy. That is, linear economy transitions to the circular economy. So I challenge you, how will you integrate circular thinking into your project? Maybe it is a thesis or recycle composition on internship with your remanufacturing firm, or even a startup focused or upskilling their wastage. The opportunities are endless. Let's engineer our sustainable future together. Now we can start the topic in basic itself. Yes. What is a circular economy? The circular economy is an economic system designed to eliminate the waste and continually reuse the resources. Unlike our traditional system, take, make, dispose model, we are already well aware about that model. It focuses on closing the loop, ensuring the material stay in use for a long possible through recycling, remanufacturing, and regeneration. So think of it like nature. In a forest, fallen leaves decompose and some new growth, nothing is wasted. The circular economy applies this principle to industries, product, and infrastructure. The linear versus circular economy. Now to compare the two models, the linear economy is take, make, dispose. That's it. We exact raw materials, manufacture product, use them, throw them away. That's it. Here the problem is it's wasteful, polluting, as well as unsustainable. By 2050, global waste could increase by 70% if we don't change. Just to think that. So the circular economy we introduce, that is resource, reuse, recycle, instead of take, make, dispose, right? So the circular economy highlighted reduce, reuse and recycling. So the product are designed for longevity, durability is high, then repairability and recyclability also. So waste become a resource, materials are recovered and fed back into the production. Example, instead of discarding a smartphone, we refurbish, resell, or extract metals for new devices. The circular economy is built on three core principles. One is eliminate the waste. Not only eliminate the waste, even they eliminate the pollution also. Design product so they don't create waste. Example, biodegradable packaging. Second, keep materials in use. Extend product life through repair, remanufacturing, and sharing models. Example, leasing instead of buying, right? Then regenerate natural systems. Return nutrient to the environment. Example, compostable materials, generative agriculture is the example of regenerate nature. As engineers, you can influence all three through smarter design, material selection, and process innovations. Why should engineers care? The thing is resource scarcity. Critical metals like lithium, yes, cobalt, or finite, right? So circular design reduce dependency. Second one is regulatory pressure. The governments are enforcing stricter waste and recycling laws. Example, circular economy action plan forcefully to forcefully to follow. All the government should strictly to implement that law. Then not in India, in global wise. Then cost savings. Third one is cost savings. The reusing materials cut production cost. Compare like Tesla recover 90% of battery materials. Then innovative opportunities also. Circular economy drives new tech, 3D printing with recycled plastics, modular constructions. These are the example for innovative opportunities. In short, circular economy is not just good for the planet. It is the future of smart as well as sustainable engineering. Right? How circular economy works from raw materials to regeneration, this age to this age. That is the circular economy.
Where you come back from?
The circular economy cycle. To understand how a circular economy functions, let's break it down into a continuous loop. No more dead ends, only cycle of renewal, right? The first, we can see the raw materials using renewable, recycled, or bio-based materials like bamboo instead of plastics, recycled steel. Then production, manufacturing product for durability, repairability, and easy disassembly. Example, modular smartphones. Then consumption, encouraging sharing, leasing, and product as a service model. Example, car sharing platforms. Next one is recycling. Extracting materials from waste to feed back into productions. Example, lithium from old EV batteries, right? Then reuse. That is upgrading used product. Example, remanufactured industrial machineries. We can reusable. Then regenerating natural resources. That is reshorting ecosystem through biodegradable materials and clean energy. Example, compostable packaging. Unlike the linear model where waste is the end, right? But the circular economy keeps resources flowing just like natural's own cycle. So the circular economy in key sector, how this apply across different industries, like each with unique engineering challenge and the solution also. Example, here I am just taking three sector: manufacturing, agriculture, and energy. The manufacturing, example, automotive industries, reusing scrap material and recycled plastics in new car. Here the engineering role is designing for disassembly. Example, standardized screws, then separable materials like, then agricultural sectors, converting food waste into biogas or fertilizer, closed loop farming. Here the engineering role is developing previous agriculture technology to reduce waste as well as chemical waste. The energy sector, repurposing old wind turbines blade into construction materials. Here the engineering role is innovating in energy storage, second life EV batteries for grid storage. These are the examples. In all these sectors, the engineers are key to closing the loop, whether through material science, process optimization, or waste to energy tech. Why should you as engineers care about this cycle? What is the role of exact in engineers? That is waste equal to resources. Your design can turn trash into treasure, right? Example, Apple robot Daisy recover gold from iPhones. Energy efficiency. The circular system often use less energy because recycling aluminium saves 90% of energy versus new productions. Future proofing industries also. The companies adopting circular practice.
How are you? All
Yes, the companies adopting circular practice will lead the market. Your skill in design, automations, and system thinking will drive these transitions. So whether you are designing a zero waste factory or a biodegradable product or a smart grid, remember this, every engineering decisions can either contribute to waste or to a sustainable loop. What is the benefits of circular engineering? The engineering field, what is the benefits of circular economy? First one is environmental benefits. Healing the planet. The most urgent benefit, protecting our environment. Circular engineering directly tackle two critical crises. That is waste and climate change. Waste reduction. That is, the world generate 2 billion tons of waste annually. The circular design prevent landfills by reusing materials. Example, Adidas, Future Craft, Loop shoes are 100% recyclable, right? No glues, no waste. Second, CO2 and pollution cuts. Circular system reduce emission by 40% in sectors like construction and manufacturing. Example, using recycled steel cut CO2 by 58% versus virgin steel. As engineers, you can be the ones designing product that leaves zero waste behind. Then, what is the economic benefit? First one is cost savings. Second one is creating markets. Yes, I mean new business model should be created. Circular engineering is not just green, it is a profitable. How? First one is cost saving. That is reusing material slashes production cost. That is example Renault, right? It saved 30% by remanufacturing car parts. Then less dependency on volatile raw material prices like ethylene, rare earth materials, metals, these are the example. Then new business models, a product as a service. Yes, today I'm just giving one example for Plips light as a service. I'm just to explain in that back. Next slide, right? So it is a new business model. So it is it's one of the economic benefits. Then startup thrive in recycling tech, precious plastic machines for local plastic recycling. The circular economy could generate $4.5 trillion in global economic growth by 2030, 2030. The engineers will drive the shift, right? So third one is social benefits, that is job creation and sustainable, that is communities. Finally, circular engineers create positive social impact because the recycling and remanufacturing create more than jobs landfilled. And this statement is given by International Labour Organization, ILO. In every few slides, I'm just to giving their statistical data. That statistical data getting from SESIM, right? It is one of the most familiar data, statistical given data. That is, it's one of the data storage, right? So it's a data analytical platform also, SESIM. You just to try to search it. It is most 99 percentage. It's a we get that platform through truthable data. Okay, I'm just to get it from that SISIM only. But SISIM, it's not a open search engine sources. It is, we want to pay, we access SISIM, we want to pay the institutional level, we will get it. We want to pay more than 20 lakhs per annum, right? Our institution, my institution, I'm working on institution, that institution getting their SISIM. So I'm having their free access. So that's why I'm getting their data in very easily. If you want, you search it, SISIM. It's a 99 percentageable truthable data, we will get it in any sectors. Then the circular economy action plan aim to create 7 lakh new jobs by 2030. Yes. So we can automatically, we implement that circular economy, automatically the job creation, the employment opportunities also possibility. Then sustainable communities, the local recycling hubs empower waste pickers. Example, waste pickers alliance in Brazil. So the cleaner air, water from reduced pollutions improve public health also. So it's not just about technology. The circular economy, it's not just about the technology. It is about designing a fairer as well as that healthier world. Then circular economy in actions. I'm just giving some few case studies because we want to, the circular economy really, it's benefit for some companies, it's a provable things. That's why I'm just to sharing that case studies, right? So the first one is first case study is Flips paper Lux model. That is, first one is breaking the linear model. The Flips lighting now signify revolutionized the lighting industry by shifting from selling bulbs to selling light. Different is there. Selling by bulbs to selling light as a service. Why this matter? Because old linear model, customer buy bulbs, using them, throwing them away, then buy new ones, right? That is old linear model. Here the result is constant waste, energy inefficiency and recurring cost also. But new circular model, pay per lux, that is the name of the new model, new circular model of Philips. Philips owns the lighting equipment. Customer pay only for the light they use. Simply says like a subscription, that's it. Philips handle maintenance, upgrade and end of life recycling. So here this model eliminate planned uselessness. The system is designed to last. Here the engineering the circular design. To make this work, Philips engineered lighting system with circular built-in modular design. That is, fixture use standardized replaceable part like LED module, then drivers, everything. Then here the engineering role of Philips is designing for easy disassembly with snap fit component instead of standard. Then material recovery. 90% of materials are recyclable. That aluminium, gas, PCBs inside of the lighting, everything is recyclable. Here the innovation is Philips developed a recycling process to recover rare earth philosopher from LEDs. Here the smart monitoring is LOT, that is Internet of Technology sensor. IoT sensor track usage, predict failure and optimize energy efficiency. So here the data engineering impact is reduce overlighting and cut energy use by up to 50%. Here the circular economy outcomes. What is the outcome get it for Philips after implementing the circular economy? The results prove circularity competitive edge. The first one is environmental wins. 80% less waste versus traditional bulbs. 50% lower COD emissions from reduced manufacturing and energy use. Here, what is the business benefit? Steady revenue stream, recurring service fees versus one-time sales. Yes, it's create the continuous business. If you sell one product, that's it. Again, we want to take that effort to sell the product. But recurring service fees is not, it's continuously, it goes up for more than 20 years, more than 30 years. So that is the business benefit. Second one is higher customer retention also. Yes, we can easily to retain our customers. Definitely the customers come to again for us for the service purpose. What is the social impact? Create high skill jobs in maintenance, remanufacturing and IoT analytics. This is just a lighting company, right? It is a circular tech service provider. Previously, we can know that Philips, it is a lighting company, but now the circular tech service provider, that's it. The name also should be changed for our mindset. Why this matter for engineers? Why you know about this case study? Because the Philips model teaches 3 key engineering lessons. First one is design determinants density. Yes, your choices decide if your product can be circular. Second one is data is a circular tool. IoT and AI optimize product cycle, life cycle. This is the future of sustainable design. Business models are part of engineering. Circular solution require rethinking ownership. Who maintain control of materials. Your next design project could be a service, not just a product, right? That's why the engineers, we are expecting from engineers only, we are expecting only for services, not expecting for to do your work in your product, right? Then second case studies. Renault Group, you know that automotive remanufacturing, the overview of the company is a major global automotive manufacturer, is a pioneer in integrating circular economy principles into its operations. One of the stand-up initiative is its remanufacturing program. It's based on in the planet in France. Instead of simply recycling materials, the company focus on remanufacturing entire automotive components, extending their life as well as that reducing wastage. First, we can see what is remanufacturing. Remanufacturing is the process of disassembling, cleaning, repairing, replacing, and reassembling, right? Used product to restore them to like new conditions with equivalent performance and warranty. The Renault remanufacturing facilities, it's established 1949. I previously told like that. Previously I said it is the pioneer manufacturing of remanufacturing for that company. So now the circular economy is very famous, but that company is implemented in 1949, long-standing example of industrial circularity. It specializes in engines, gearboxes, injectors, then turbochargers and other components also. The process over 15,000 tons of part annually. Use reverse logistics to collect used part from dealership and repair centers. Then engineering and design insights. Insights, it's nothing, it's a knowledge, right? So design for disassembly. The components are now being designed for easy disassembly, repair and remanufacture. It's standardization. The parts are standardized where possible to simplify remanufacturing. The quality assurance. Rigorous testing ensure remanufactured components meet original cost. The original space. That environmental and economic impact. 70% of energy savings and 80% less raw material use compared to producing new components. Then another environmental impact is lower carbon footprint per unit. Then create skilled engineering job in diagnostics, precious machining and process innovations. Then remanufactured parts are 20 to 50% cheaper than new one. These are the impact, environmental impacts. Then what is the business and circular economy model in Renault? That is the operate on a closed loop model, collect, remanufacturing, redistribute. The extend product life cycle, add value from waste and reduce dependency on raw materials. So here the company integrates circular practice in product design, supply chain and also after sales services. Here what takeaways in that case study, the takeaways from some points. One is remanufacturing is on engineering intensive process that require knowledge of materials, machines and quality control. Second, the circular economy can be sources of innovation and employment in the engineering sector. Then engineers play a crucial role in redesigning product and system for circularity. These are the things we can take away from this case studies. Next case study is Arab and circular building. The Arab, that is a global engineering and design consultancy, is at the forefront of integrating circular economy principle into the construction sector. Through innovative projects and tools like circular building, prototype and the material passport, the Arab is demonstrating how buildings can be designed for disassembly, reuse, and material recovery, a shift from the traditional leader. I mean, the traditional linear model, build, use, demolish model, right? But how the construction sectors possible for circular economy? Here, the key concept is the problem with traditional constructions. The construction sector is responsible for 40% of global waste and a significant portion of carbon emissions also. Most buildings are not designed for disassembly. It's leading to valuable material being lost after demolition, right? Demolition, automatically everything is waste. But what are circular building? Here the design for disassembly and flexible use. Use of modular system and reversible connections. That is bolts instead of welding. So incorporate reused and recyclable materials. Here the Arab Circular Building prototypers collaborate with partners like Built Environmental Trust, then constructed a fully demountable buildings, then used pre-used steel, wood installation and cladding. Then all components were tagged with digital material passports. So these are the things, the circular building prototypes are used by Arab. Then engineering innovations here, the material passport, that is the digital record of each material specifications, origin and reuse potential, enabling future recovery and reuse. Then building information modeling, we can say that BIM, that is integration for tracking materials and life cycle data. Then standardization of components for easy assembly as well as disassembly. What is the environmental as well as economic impact for this company? That is the significant reduction in construction waste and emissions. They promote long-term cost saving by enabling reuse of high-value materials. Then encourage new business model in constructions. Example, leasing materials. What way we are takeaways from this case studies? First one is system thinking. Engineer must design with the entire building life cycle in the mind. Second one is circular building require cross-disciplinary collaborations between civil, structural, environmental engineers and architects. Then emphasis on digital tools and traceability is growing in sustainable engineering. Next, move on to the next case study is Fairphone, the modular electronics for a circular future. Here the overview is Fairphone, a touch social enterprises has revolutionized smartphone industry by designing devices that are modular, repairable, ethically sourced, and built for longevity, durability. This case example how circular economy principle can applied in the consumer electronics, one of the world fastest growing waste streams. Here, the key concept of the case study is the problem with conventional electronics. The modern smartphones are difficult to repair and design with short life cycle. Second, e-waste is a global crisis. Over 50 million tons generated annually. Then manufacturing relies on rare earth metals and conflict minerals with high environmental and social cost. Then what makes Fairphone circular? The modular design. The phones are built from individual components, camera, battery, screen, etc. Right? So that users can easily replace with your screwdriver. So repairability rated highly. Example 10 out of 10 on iFixit for user repairability. Then durability, software support and spare parts availability are extended for up to 5 to 6 years. Here the ethical sourcing also, the material like fair trade gold, recycled plastics and conflict-free minerals are used. So here the engineering innovation is design for disassembly, then standardized models, then life cycle recycling also. So what is the benefits of environment and economic impact? Here the extending phone lifespan by just 2 years can reduce the CO2 emission by 30%. So the modular phones reduce demand for virgin raw materials and lower waste. Then Fairphone challenges the planned, especially the models, and promote product as a service models. So what is the business model here to use? That is product as a platform. Encourage customers to upgrade part, not replace the entire phone. Then focus on transparency, supply chain ethics, and community repair networks also. It's empower the shift from ownership to responsibility as well as the maintenance of the consumers. So here what takeaways from this case study is engineers for circularity means focusing on durability, repairability and ethical sourcing. Design decisions affect the entire product life cycle and environmental impact, right? So the modular thinking can be applied to other electronics, machineries and system. Here I'm just to given 4 case studies. One is from electrical, right? Second one is construction, right? Then what is the case studies? Please, anyone, please tell me what are the sectors we have discussed that case studies. First one is electrical, second one is automotive, third one is construction, then last one is the discussion part is most important, na? That is electronics. So the each sectors I'm just to given one example. I hope that this case study is helpful for you understanding how the circular economy proof those sectors in successful manner, right? Then during the implementation of circular economy, what are the challenges they are facing? First one is, yes, high cost and economic viability. That is upfront cost for circular design, remanufacturing equipment, or sustainable material can be high, right? Then circular product, example modular phones or disassembling buildings may cost more initially than traditional alternatives. The ROI is often long term, making it less attractive to business focus on short term profit. These are the first challenge. The second challenge is regulatory and policy barriers. The outdated regulations may favor linear systems. Example, incentives for new manufacturing versus reuse. Lack of standardized guidelines for manufactured part or reused material can limit scaling. Then cross-border logistics for reused component can be legally complex. It is the major challenge, right? For example, the reusable product just to be imported, export from India to China or India to Gulf country means it's very difficult. Yes, to compare it because the legal complex is more different to compare the new product export. So these are the challenges in the regulatory areas. Then third one is technical limit of recycling and reuse. Some materials, example, composite plastics, then mixed textiles are difficult or impossible to recycling efficiently, right? Then downcycling is common. The material lose quality after reuse. Then product complexity and lack of design for disassembly. Hinter component recovery. Then what is the need? Last challenge is need for systematic change. Circularity require rethinking entire system from supply chain to consumer behavior. The lack of collaboration between designer, engineers, manufacturing, and recycler. The business often operate in silos and shifting to circular models demand new business strategies. Example, leasing versus ownership. These are the major challenges involved in the circular economy. But why these challenges is aware about engineering students, especially you. That is, the engineers are central to solving these challenges, right? So through better design, innovation in material and process, and system thinking also. So understanding the barriers help the students create practical and scalable circular solution. So every engineering students, the circular economy challenges and barriers understanding is most important, right? Next, what is the opportunity for engineers in the circular economy? First one is material innovations. Develop sustainable, recyclable, biodegradable, biodegradable materials. Example, bio-based plastics, low carbon concentrate. Then engineer smart materials that can signal wear, that is aid disassembly or self-heal. Then innovate in material recovery, that is improving recyclability or developing substitute for rare or taxes input. Then second one is product redesign for circularity. Apply design for disassembly to make product easy to repair, upgrade or recycle. Create modular system for electronics, vehicles and appliance. Redesign to extend lifespan, support maintenance and enable remanufacturing. Third opportunity is new circular business model. Support the shift from ownership to product as a service. Example, leased electronics, pay per use equipment. So the work with business to create reverse logistics systems, and material take back schemes. Enable digital tracking of components, digital twins, material passports, etc. The engineering demand in key sectors, for example, automotive sectors, that is remanufacturing, the battery recycling, vehicle as a service. In construction field, construction sector, design for reuse, circular material, smart building systems, electronics, modular design, e-waste recovery, right to repair solutions, right? The additional growth areas, textiles, packaging, or renewable energy, tech, etc. The each sectors I'm giving their example of that case studies, right? The automotive, constructions, electronics, electricals, like that. Then the circular economy skills are in high demand from sustainable product development to supply chain redesign. The engineers are essential to making the circular transitions practical, scalable, as well as profitable. This field, innovative, purpose-driven careers and combine technical excellence with sustainable impact also. Then go for next, future outlook. The circular economy in the next decades. The circular economy meets Industry 4.0. The integration of digital technologies is accelerating the shift to circular systems. The AI and machine learning optimize the material use, predict maintenance, and enhance product lifecycle decisions also. Then IoT, Internet of Things, that is enabling real-time tracking of product and materials, supporting repair, reuse, as well as that return loops also. Then blockchain, ensure material traceability, support material passport, and build trust in circular supply chains. Example, smart sensor in construction materials can track structural health and signal when part can be safely reused. Second, global policy and regulatory trends. The government and global bodies are pushing circular through policy. Example, Green Deal sets target for sustainable product design, repairability, and circular material use. Right to repair laws, expanding in the Europe countries, US, and other regions, encouraging modular and serviceable design. Of course, the circular economy, the initially to need the high cost, so the developing countries, underdeveloped countries, little bit facing their difficult to use the circular economy. But the developed countries are always encouraged to using this concept. Then extend producer responsibilities, that is extended producer responsibility. We can say that EPR, right? The producers are increasingly held accountable for the entire life cycle of their product. The role of young engineers. What is your role in the circular economy? First role is young engineers are uniquely positioned to lead these circular transitions by challenging linear assumption in design and manufacturing. Then using system thinking and digital tool to solve sustainability problems. Then driving innovation in startup, corporate research and development, R&D, and public policy. First, you want to be mindset. What mindset you want? That mindset is how can we make this product cheaper too? How can we design this product to never become waste? That mindset is needed for every engineer. The future of engineering is circular, a field full of technical challenge, environmental impact, and creative opportunities. At least the next generation of engineers won't just design machines, they will design systems that regenerate values. Very all the best. If having any question and answer, please. I hope that many of the students the first time to hear the words of circular economy, right? I hope that this sessions it's very helpful for you to understand at least the new concept what's going on in the global, especially in the engineering field, right? Please students unmute and discuss few questions. Please. Any questions? Please unmute to discuss some questions, some clarifications. Okay, thank you. Few of them at least to send a response in the chat box. Thank you so much. Okay, if you don't have any questions, please leave the meeting. Thank you. Please welcome. Have a nice day. If any new concept in further classes, do you feel that classes you need to feel like that, please share that Eduwing management. I will ready to take the classes. Okay. Thank you.